Hello, everyone. Welcome to Karmada community meeting. Today is April 28th, 2026. Um, we today we have quite a lot of items on today's agenda. Um, 就 would you mind let Yung Woo Song go first because it's getting, I guess it's getting quite late in his time zone.
Yeah, no problem. Yeah, that's
Mm.
fine.
I, I'm not sure if I pronounce your name right correctly. Yung Woo Song, right?
Yes.
So would you mind go first?
Oh, okay. Should I share the screen um or
Yeah,
just
sure.
yeah, okay.
Share your screen would be great, I think.
Oh, okay. Uh, can you see the screen?
Yeah.
Yeah, sure. Yeah.
Okay. Hi everyone. I'm Jungwoo and I'm work work as a solutions architect at AWS, and in these days I spend a lot of my time helping customers learn AI workloads on EKS and multi-cluster GPU serving with Carpenter or CAS. And through this work, I got interested in Karmada as the best fit for cross-region replica scheduling in those environments. And that's what led me to this contribution. And I'm uh, introduced about the some issue and what I contributed to the community. And when when the customers use dynamic weight with available replicas with Carpenter, and it doesn't work right now because the current estimator only counts existing nodes. So if there are zero nodes, it reports zero available replicas. But Carpenter needs pods to exist before it provisions nodes. So no pods because no nodes, and no nodes because no pods. And this is something I've seen firsthand with my customers. When the customers learning GPU inference across regions, region A with insufficient capacity error, and the customer need replicas to shift to region B automatically, but um, the feature is not working right now. So I try to contribute to node autoscaler estimator plugin. This is just a plugin that leads Carpenter node pool and subtracts current node claim uses to calculate how many replicas could fit if nodes were provisioned. So it's just a best effort estimate based on organizational limits, not actual cloud capacity. Yes. So this is a brief introduction about the issue and my peer, and you can see um, the link in the meeting notes. So yeah, that's just in introduction.
Anyone have some questions? First of all, I think this is a, a great proposal, a great feature, I think. And I think the proposal is very thoughtful. I just left one comment on that issue is the the node scaled the node new scaled may be different with the legacy nodes. So can you open that issue? Let's see.
Yes.
Yeah.
This one.
Here. Yeah, sure. I just have these comments, but I don't think this is a blocker. So
yeah, I agree with you, and I think we have to discuss about the gRPC interface because there's only max available replicas right now, but when we try to handle the potential capacity and right now capacity, we need to add some fields for handling the handling both capacity. So I think we need to change the gRPC interface for this. So I just want to know the other contributors' feedback or ideations. Yeah, this one.
Hello, Wei Cheng. I remember you opened PRs for the DRA support recently, right? I think just I guess when the for the DRA feature also we also need to extend the node plugin, right?
No plugin. So you mean the interface?
No, we sorry the node node autoscaler estimator plugin. I'm sorry, no.
Yeah, for my for the DRA, I just simply like need to change the spec of the resource binding to add a resource claim name, resource claim reference, and the gRPC interface for estimator will not be changed.
Okay, sure. Never mind. So, okay. Here I have another question, maybe beyond this proposal itself. I want to just just out of curiosity, how is your customer running Karmada in AWS?
You mean their workloads or just use case?
So, I wonder how the Karmada instance deployed in on AWS. Is there a managed Karmada on AWS, or the Karmada is deployed by your customers?
They just try to use the Karmada as a POC just for concept. So they just deploy the open source Karmada, not manage the Karmada on EKS. So
Okay.
and I handle a lot of customers of AWS, and I in these days I've met a lot of customers consider the multi-region and multi-clusters because the GPU capacity is insufficient. So they are all of them just considering the multi-region and how to allocate the GPUs or GPU instance or GPU pods between the clusters and region intelligently. Yeah, so that's a use case for my customers.
Yeah, that's very typical use case. Okay, let me see. What's next for the proposal?
Yeah. Hi. Can you hear me?
Yes.
Yeah, sure.
Yeah. I'm John. I want to discuss the implementation part. I have left a comment in your pull request.
Yes. This one, right?
Okay. Oh yeah, this one. Yeah. I can see. Now you introduce a new plugin. To do the work. To aware the potential capacity, right?
About gRPC interface or
No.
about this comment?
Sorry.
He's
I mean you. Yeah.
sure,
I mean you
go.
introduce a new plugin.
Yes.
Yeah.
About the
Yeah, and then you use the setup flag plugins to set which plugin to enable and disable, right?
Right.
Yeah. I want to discuss. I think this feature is extension of the existing node resource plugin. So I wonder whether we can just integrate this feature into the node resource plugin instead of introduce a new plugin. Yeah.
John, I want to confirm with you. Do you are you considering the new plugin will affect the node resource plugin, the legacy node resource plugin?
In fact, the new plugin, which called the node autoscaler, it will calculate the available replicas based on the existing nodes and the potential node pools. Yeah. So if the user enable the two plugins together, they will do the calculation twice.
Yeah.
Yeah. It's kind of
waste of
kind of waste.
Yeah.
Yeah.
I totally agree. Yeah. And
just waste, no conflicts, right?
Yeah, no, there's no conflicts, just overwrap. Yeah. The node resource plugin overwrap the node scaler plugin. And actually I left the comment 2 hours ago, and this is intentional mechanism because I just wanted to preserve the existing behavior by default. And I also very, very agree with you because it can be misreading and I understand it wasting the computation. And yes, but I think when we try to support combining multiple plugins at the same time, like node resource plugin is for the setting mechanism and the node autoscaler plugin support the only dynamic potential capacity. When that time we have to design again and change again the framework's aggregation logic because there's only mechanism for aggregating the capacity with just minimum, just check the minimum. So I think this is a very large change and it can be confusion for the existing Caldama user. So my proposal is to keep the current structure and add a startup validation that rejects enabling both node autoscaler and node resource plugins at the same time with the error message.
Yeah, I agree. I think it's a feasible way to do the validation when the startup. I don't think we need to change the framework to now because I don't mean the computation of the two plugins. I mean just the one plugins, just one node resource plugin, and we can introduce a new startup flag. For example, enable node autoscaler. When enable the flags, the node resource plugin will take the potential Carpenter node pool into account. When this flag is disabled, the node resource plugin will just do the work, just take the existing node into account. Yeah.
So basically, your idea is to implement this Carpenter feature inside of the node resource plugin, right?
Yeah.
So something like there's a flag in the node resource plugin. If the flag is enabled, the node resource plugin can see more nodes, as you mentioned, take the potential node pool into account.
Yeah.
Yeah, I think that is maybe an alternative approach, but not sure. I don't have a chance to look into the course yet.
Yeah, I think both are okay. I just want to raise this up to discuss the question. Yeah.
Yeah, sure. I got it. Thank you. Okay, I think I can take a look at the PR and leave my comments there once.
Okay, and I stopped sharing the screen.
Okay, thank you. Thank you.
Thank you for this awesome proposal.
Sorry, just to double check. So the auto scalar estimator only supports, looking from the code, only supports the estimate replica, right? Doesn't support the components.
Sorry, I missed your
Oh,
context.
just
Sorry.
from the checking the auto scalar estimator code. Right now it only supports checking the estimate the replicas, makes available replicas, right?
Yes.
Got it.
Yeah.
Okay, yeah. Thank you. I will also take a look at the patient and proposal. Thanks.
Thank you.
Wichan, do you have more questions or is that it?
That's it. Yeah. Thanks.
Okay. Yeah, this is an awesome proposal. I'm looking forward to seeing it implemented. Let me share my screen.
Do we have enough time for all of this, Joe? Do you
Maybe
think?
not. Maybe not. We'll just get through what we can get through, and then for anything else left over, then we can just push them to a future meeting.
Okay. Okay.
This one is very important. So we have so for manage multi-cluster platform built atop Karmada, we have tenants that operate at very large scale. One of them that we're currently working with to onboard onto the platform is our internal pass tenant. And they operate at very large scale and care about flexibility. They want to be confident that Karmada will be able to power workload distribution for them at the very large scale that they operate at. And they're starting to ask about how scalable Karmada is, which is why I submitted this proposal so that we can get an updated Karmada scalability test report. The last one that was published was in October 2022. This was very good, and it um, it detailed Karmada's scalability capacity. But this is very outdated. So when they asked me about how whether or not Karmada can support the very large scale, I will point them to this, and then they'll come back and say, "Oh yeah, but this was 2022." So I think it would be awesome if we can get um, a new scalability report, um, which will give users um, strong confidence that Karmada can actually power their workloads at very large scale. This proposal is very detailed, so I will just go over some of the main points. The first one is that the most recently published report, right, is very old, right? So users would like to get a more recent report. Um, so that's one reason why I think we need this. Another reason is for adoption, right? Usually the reason why you want to invest in multi-cluster is because operating at one cluster just does not make sense. So usually when people start operating at the multi-cluster level, they'll have many clusters. And usually those will be platform teams that operate at large scale. So having very clear scalability data to help inform their decisions will be very helpful with adoption. not just for platform teams at Bloomberg, but also for other people who want to use Karmada for multi-cluster orchestration. Also, since 2022, there's been a lot of changes to the project. A lot of those changes have been optimization to some of the components. So I'm also personally very excited to see how much improvements we've made since the last report was published in 2022. And also for managed platforms like ours, as I mentioned, this is very important because every use case is different. So at Bloomberg, we have use cases for multi-cluster orchestration ranging from AI, so Wei Chen's team, to analytics, Mihash's team and Mihash's group, as well as general utility compute for our platform as a service internal offering that powers workload distribution for general utility compute use cases for the entire company. And also having this will reinforce Karmada's production readiness and stability and will send strong signals to the community about the project's maturity, right? If we publish this data, then people will know for sure that they can rely on Karmada to operate at very large scale. But if this data is not readily available, then that will raise some concerns for people, right? They might think, well, if you don't publish this data, maybe there's something you're hiding, right? Maybe there are limitations of Karmada that I might run into after I adapt it, which would not be an ideal scenario. So the proposal is to first start by publishing an updated scalability report as a first step. And then initially, I think it would be awesome if we can get to a place where we do something more automated, like what SIG scalability currently does for Kubernetes. So for Kubernetes, there's no snapshot scalability reports that get published on some cadence. All of that is automated, and most of that work is done by SIG scalability. And that group has tooling that actually automates all of the scalability testing. Let's see if I can pull up a dashboard. I think we can learn a lot from what Kubernetes scalability is doing and leverage some of the existing approaches that they take to solve these type of problems for Karmada. A lot of their processes and how they do scalability testing is documented here. So I think we can borrow some of their expertise and processes for Karmada. Let's see. They have a very nice dashboard that shows scalability data based on the automated testing. Let's see. Oh, maybe here, I think. Yeah. Ensuring routers ideally. Let's see. Yeah, so they have automated testing. So for instance, WeChain is looking into DRA. They have many different type of tests. I haven't gotten a chance to do a deep dive into this, but I want to at some point. But I really love how a lot of this is automated. Let's see if I can look at this one. Yeah, they have tooling that they use that we can also use. I think in the previous scalability test that we used cluster loader, yeah, cluster loader 2. So we already are have used some of the tooling that they use. So there's a lot of data about all of the automated scalability testing. This will take some work, so I don't think this should be the first step, but if we can get here eventually, I think that would be awesome.
Mhm.
So that's this proposal. What do you guys think?
Joe, are you still proposing update the test report, right?
Yeah. So I think something like this would be a good first step, right?
Okay.
Getting to the point where this is automated will take a lot of work. So I don't think we should aim for that for now. For now, we can just get an automated test report.
Mm-hmm. So run the run run the performance test needs a lot of work to do. Also needs a lot of resources.
Maybe we can use some of these tools like cluster loader, and we probably don't need real Kubernetes clusters.
Yeah,
I
sure.
think, yeah,
We need we need to a way to fork fake Kubernetes cluster.
yeah. I think that should also work.
Yeah.
The one problem is the member cluster. Take some member cluster is very easy, but you still need a very big machine to run the Karmada itself because we to test much
Yeah.
resource it will cost.
Yes, I think we need a machine where to host the Kamada instance.
Mm-hmm,
Absolutely a big machine.
mm-hmm.
But that's not a problem. We have the machine, I think.
Oh, that's awesome.
So Joe, are you going to have a try? Oh, I can see the machine is not a problem.
Okay. If I can try this?
Mm-hmm.
Yeah.
Sure.
I want to try it.
Okay. I maybe I will talk to you on Slack how to provision the machine. But maybe you can. I will give you a public cloud account where you can create the instance you need.
Awesome. Nice. Okay. Yeah, I want to try this because this will be very helpful to know
Mm.
just at what scale we can use Karmada and where the limitations are. And once we find limitations, then that will inform what we should focus on to make improvements to the project.
Mm.
But without this data, we won't know.
Okay.
In fact, recently I'm running some similar test our in my environment because we, in trip.com we want to test Mother how many data can run on Kamada 2, and there's some known limitations. Mm, The first one is memory. If you put a lot of data on the Karmada cluster, the memory will be very huge. And 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 the second one is a very strange. I ran into a gRPC message size limit about 5G bytes and 5.6 G bytes, and it said the gRPC limit, and the control manager can't start. I guess the problem is the API server can't list the resource from the etcd. I'm still digging into it.
Okay. Yeah. Thanks for sharing. Can you please add that to this issue? I think it would be very helpful.
Yeah.
Okay.
I'm still tracking into it, so I guess I still need some time. I need to find some time to dig into.
Okay, thanks. Any other questions or comments about this? Okay, thank you. Let me go to the next one. So the next one is for conformance testing. So today, if you have a Kubernetes cluster, you can use a tool like this one to actually run a test suite and validate whether or not it's a conformant Kubernetes cluster based on the CNCF conformance testing program. And I think something similar would be very helpful for Karmada. So for our managed platform, we have a versioning support policy, very similar to Kubernetes version support policy. We basically have support for the most recent 3 minor versions. So right now, versions 1.17, 1.16, and 1.15 are supported. And anything older than that is deprecated. And once deprecated, we send our users alerts to encourage them to upgrade. With Kubernetes, whenever we add support for a new version, we can just run the CNCF conformance test suite using this tool to ensure that the new version is conformant per the test suite requirements. But today, unfortunately, there's nothing similar for Karmada. So when a new version comes out, before adding support for it, I will go, it's very tedious and suboptimal process where I'll like look at the release notes, then I will run it and try to do as much testing as I can. But that's not very ideal. It would be much better if we had a test suite. And to begin, it doesn't have to be super comprehensive. We can start with very simple things like, hey, workloads will get spread across clusters, and then maybe later on we can add more tests for things like more complicated things like failover. But to start with, I don't think it needs to be super comprehensive. It can just cover some common use cases. And then over time, once we have the foundation, then it can evolve to be more comprehensive and support more complicated like failure scenarios and so on and so forth. I added some reasons as to why this would be helpful, right? The first one is what I just mentioned, right? Like today, when adding support for a new version, so recently I added support in our managed service for 1.17. It would be nice if I can, before adding support for it, just have a test suite and then use this tool, just point it to the Karmada API server, have it run some tests, and then give me a test report to know whether or not that new setup conforms to what we want it to conform to. The other one is how this can be a barrier to enterprise adoption. So like in some corporate environments like ours, um, some things usually need to get approved, right? And usually documentation or reputation alone is not enough. So you want to have some artifact like some conformist tests. And this is very helpful for things like compliance and auditing. Um, so this can be a barrier to enterprise adoption, right? In very regulated enterprise environments, compliance and auditing is very important. So when adding support for a new version, ideally you should have some artifact to, in the form of like some conformance test report to show that this new version is conforming and that it won't introduce any risk that may compromise existing infrastructure. So that's very important. I also added a reason for multi-cluster platforms like ours built atop Karmada. Um, for these type of things, we're managing not just one Karmada instance, but a lot of Karmada. We have a lot of Karmada instances across multiple environments for other platform teams. So the impact and um, blast radius is very huge. And introducing support for a new version for which there may be some issues can cause undesirable consequences at very large scale, right? All of the Karmada instances power entire platforms, right? Like platforms for analytics, general compute, as well as AI. So with any new change introduced, there's a lot of risk, and having conformance testing would help to de-risk a lot of that. And also something like this will send strong signals about project maturity, not just for end users, but for the wider ecosystem, right? Kubernetes has this, and that sends a very strong signal about the fact that Kubernetes is very mature, right? Without this, every cloud provider maybe can just run their own contribution that will have different behaviors. So I think that's another reason. And I think Karmada is at a point where we can do something like this. And then the last reason I added on here is how this is already a proven model, right? We have this for Kubernetes, and actually recently, uh, there's a new conformance program that started for to standardize AI workloads running on Kubernetes. So this is already a proven pattern that we can adapt for Karmada. I think this tool is, as far as I know, the most commonly used for Kubernetes conformance testing. And the nice thing about this tool is that it's extensible via a plugin architecture. So to make this work for Karmada, we can just add a Karmada plugin that will run the Karmada test suits. So what do you guys think about this? Okay, can you hear me?
Yeah, sure.
Yeah, any thoughts about this?
Yeah, I think as you mentioned, we need some we can have some basic test get started.
Yeah.
So I don't think that any technical issue or because now we have a lot of end-to-end tests now, so I guess all we need to do is to label some tests as the conformance test, right?
Yeah, that
So
would be awesome.
yeah. But I have a different opinions on the certificate program.
Oh, so I oversold that part a little bit. I don't think maybe we don't need that.
Yeah,
Yeah.
I think we need that eventually, but not
Uh-huh.
now.
Yeah. I agree.
Yeah. The first reason is now we uh as you see as you see the items in this year's roadmap, we are going to promote our APIs, and maybe we can run the program after our API are stable.
Yeah, that would be awesome. So
Yeah.
and then yeah, and then like so this is the repo for Kubernetes conformance, right? When we
Yeah.
get there, maybe something similar. We can have something
Yeah.
similar. Yeah,
Yeah.
that would be
Uh,
awesome. Yeah, that would be awesome. Yeah.
there will be a long way to go because
Yeah.
we need to cooperate with all the vendors and let them know before we run the program. Make sure they get ready for this.
Yeah, I agree. Yeah.
Mm.
Yeah, but when this happens, I think that will be awesome and will send a very strong signal about Karmada's stability and maturity.
Yeah, sure.
Yeah. Okay. Yeah. Any other questions or comments about this?
Speaking of the Kubernetes conformance test, in Bloomberg, you never run this test, right?
For Kubernetes clusters, we do. We have
You,
we have
but
um, yeah, go ahead.
but you don't have to upload the test result to the repo, right?
Oh no, we don't upload it because this is for an internal platform.
Yeah.
Yeah, we're an end user and not a cloud provider. So we do the conformance testing for new versions of Kubernetes
Okay.
just to make sure that
Uh,
the clusters are conformant, but we don't publish the test reports.
yeah, sure.
Yeah.
If you look into that repo, you can find a lot of PR from from me.
Oh yeah.
So yeah, I seen
Okay.
a lot of PR for the
Okay.
conformance. I know the conformance program
Oh nice.
very
Okay.
much. So
Okay. Yeah, and you think eventually something like this will be awesome for Karmada too, right?
yeah.
Yeah, okay. Yeah, I agree. Yeah. Okay, so that's this. We already went over this. Oh, I also want to talk about this. So last time
Okay.
I did a demo to go over this, I've been working on the DAX for this. It's not done yet, but I can show a preview. I want to get this done by like sometime next week. Most of the structure and content is done. I just have to polish it. So today I'll just show you the structure um, to hear what everybody thinks. If I look at this preview, so the reliability guide is here. I went over this last time, but it wasn't very early drafted. So I polished it based on some of the feedback from last time. So for all of the objectives of thresholds, given that all you did the testing to show what things will look like when things actually break, I went back and adjusted the thresholds. And also I let users know that these thresholds are not set in stone. They're recommendations that they can change based on requirements they have. Uh, let me, based on requirements they have in their environments. Let me, wait, 1 second. Let me, so in the doc, I mentioned that all of these are suggestions and that users can change them based on need, depending on what they want for their environments. I also polished the SLO alerting framework info so that users know how the alerting is set up. And I talk about SLAF and how it helps with generating the Prometheus recording and alerting rules, and added instructions for how they can use this tool to generate the rules for their environment. So here I show an example. This one, I show an example using the Karmada API server availability SLO. And then what the generated Prometheus rules will look like once they use SLAF to generate the rules. So I add some documentation, and then I show them how to load the rules into Prometheus, whether or not if it's like Prometheus running on servers or if it's Prometheus deployed on a Kubernetes cluster using Kube Prometheus stack. And also I added some links to the dashboards that they can install to know how the Karmada components are performing. These are open source dashboards that they can download. And also so the default config has suggestions for the thresholds and the objectives. So this is the default config. And I allow them to download this config. So here they can just download this config. And then they can either use it as is based on the recommendations. So I say, hey, I mentioned for the users that these are recommendations and those thresholds and objectives can be changed if they need to based on the requirements. And here they can download the default config and make changes if they want to. And also, when things are not working as expected, that's a problem, and the users will need to know how to fix the issues. So I also added runbooks for all the SLOs. So this is a list of all the SLOs for API server, policy application, scheduler SLOs, resource propagation, cluster health. And then I added a runbook for each. So the runbooks are here. So for each one, this is still in draft state, but the structure is already in place. I just need to go and polish this and add some instructions based on observations from our environment. We've run into a lot of these issues already. So for a lot of these, I already know what the potential causes are and how to fix them. So for each of the runbooks, I explain for the users exactly what it means, how the alerting is set up, what the alert means, what type of impact it can have for their workloads, possible reasons why it can happen, and then how to fix, and then instructions for how to fix the issues. And I also add some related resources so that users can learn more about things like alerting, service level objectives, so on and so forth. And there's going to be a run book for all the SLOs. Yeah, so this is still in draft. I have to go and polish them, make them look nice. But this is what the structure will look like. This is the main page with the guide. And then here there's instructions for the users so that they can set everything up. It's very simple how to set it up. They just have to go and actually generate the rules and then load them into Prometheus. I add some documentation so they can look at SLAF and see how that works. Slav has nice dashboards for the users. And then the run books, because when things break, we have to tell the users what they can do to fix them. Yeah, so this is basically what it will look like. So just let me know what you guys think.
Joe, thank you. Just one quick question. I see you introduced the run books concepts in the website. So my question is, what's the difference between the run books with best practice?
Oh yeah, so run books is actually an SRE best practice. I can show you some parallels. 1 second, let me show you.
SRE best practice.
Okay. Yeah. So maybe they talk about, this is a great book actually. So SRE.Google. So
yeah, I read that book.
Yeah, this is an awesome book. This one, Site Reliability Workbook and these two are great books. I don't remember which one, but in at least one of them they talk about maintaining run books for, so like in a production environment, you will have someone who's on call, and when things break, that person needs to know how to fix them. It's not ideal if they always start from a blank slate, like something in Karmada breaks, and then they have to start from scratch to figure out how to fix it, which is why runbooks is an industry best practice. With the runbook, you can just go look at it and get instructions on how to resolve the issue. So for instance, let's say let's say for instance, okay, I'll give you an example. So for the work sync, let me go back. Actually, before I do that, so Kubernetes, let me show you some examples. Kubernetes mixin runbooks. I'll show you some examples. So there's this project called Kubernetes mixin. It's similar to what we are doing. This project comes with some alerts, as well as dashboards for Kubernetes. An example is an alert if, let's say you deploy a deployment to your Kubernetes cluster and then the pods just can't run because there's no node that satisfy the resource limit. The deployment will get stuck in the rollout stage and will never get successfully rolled out. If that happens, you would like to know. And this project has a very comprehensive list of alerts, one of them being an alert for that scenario that will let you know that something happened so that you can go and fix it. So if I go here, if I look at runbook, this is what the runbooks look like for Kubernetes. So let's look. Here's one, for example. Kube deployment replica mismatch. Let's say you want to have 3 replicas, but you only have enough capacity for, let's say you want 3 replicas, but only have enough capacity for 2 of them. Well, one will remain pending. When that happens, you want to get an alert, right? So this is a runbook for that. There's runbooks for a lot of other things, right? If a pod is crash looping, see? Yeah, so there's many, yeah, so that's a parallel. And many projects use this approach. Yeah.
Okay.
So for instance, Cube node unreachable. This is an alert for when a node is unreachable. A parallel for Karmada would be a cluster becoming unreachable, right? If a cluster has become unreachable, then that's a problem. So the user needs to know how to fix it. I don't have an alert for that, but if we had one, then it would have some instructions for the users to know whether or not it's some network issue, or maybe if the CS certificate and for the cluster is not valid or is wrong. There can be many reasons. Yeah. Or maybe they need a proxy to reach the member cluster, but the proxy is not set, right? So here we would add all the potential reasons why it can fail and add steps for the user so that they know how to fix it.
Okay, I see.
Yeah.
Sound like Runbook is a more detailed troubleshooting guide.
Yes.
Okay.
Yeah.
Okay.
I don't. Oh yeah, on call.
Yeah.
Book. Maybe it's not. Oh, okay. So sometimes they use the term playbook and sometimes they use the term runbook. But the concept is the same. Yeah.
Maintain. Okay.
Yeah.
Playbooks. Okay. Okay. So just CC me once this PR ready for review. Okay.
Yeah. I'll let you know when it's ready.
Okay.
Okay. Any questions or comments about this? Okay. So I so maybe so I submitted some proposals. I think we can talk more about next time, but maybe I can just briefly go over this. But basically, the Karmada search component is very resource hungry. And we have teams who want to use it. So for instance, Weichen uses this. And some of those components consume a lot of resources. I have some of those components that can consume up to like 8 gigabytes of RAM. And I've also noticed some weird issues when using the vertical path autoscaler, the VPA. I don't know exactly why, but I suspect it has something to do with GC thrashing. I don't know, maybe where CPU will also spike up, and users can spike up to 4 vCPUs. So I have some ideas on what we can potentially do to improve the resource usage footprint of this component. But I intentionally kept this issue very non-technical and high level because I also want to hear what other people think are some of the optimizations we can make to that component to improve its resource usage footprint. So we're running out of time. So maybe we can talk more about this next time.
Okay, sure.
Yeah. And then these are just some proposals. Right now, the way I'm solving this problem is by adding node pools to our clusters with nodes that have a lot of capacity. And once those node pools are added, then I'm going to add some things like affinity rules for how the search component paths are scheduled so that they get scheduled to those large VMs that have enough capacity to hinder them. So I added some proposals that will give us some flexibility for how we can influence that scheduling. This one is for topology spread constraints, and this one is for node selectors. Right now, the operator does not have support for these things. For instance, with node selectors, all I have to do is just label the nodes in that node pool with some labels and then use those labels to influence scheduling of the Karmada search components onto those nodes. So yeah, so I think we can just talk more about these in a future meeting.
Okay, sure.
Yeah. Is Wei-Chen still on the call?
Yeah.
Yeah, Wei-Chen's Karmada search components take a lot of resources.
Yeah. So basically we use it for register our pod and custom resource, and we use Karmada to provide viewing log capabilities for our users. So I guess it's also proportional to the number of pods inside our member clusters. And if there's a way to probably reduce or allow us to filter out some unnecessary pod, it might be a directions to reduce the memory usage.
Yeah, I think that's an awesome idea. I didn't look into this yet, but I think today you can only specify resource types, and there's no further filtering you can do. So today I think you can just say, hey, cache all pods, but not like pods that have some labels or pods in some namespace or something, right? Yeah, and that's how it works today, right?
Double check.
Yeah. Yeah, if that's not supported, maybe that's a possible optimization we can use. Something like only paths that have this label. Maybe.
Okay.
Okay. Yeah, so I think we can talk about them next time. Okay.
Okay, sure.
Yeah.
So the last thing, I will be quick. Is for the KuCoin China, and the deadline is coming, and anyone want to submit the CP, just remember the deadlines this Sunday. This Sunday, yeah, and also the project opportunities also in this Sunday, the same day with the CLP. So anyone want to talk as a speaker of a maintainer track or maintainer project letting talk, please let me know. I will submit the proposal this Friday, this Thursday, I think. By the way, I will take 5 days holidays since this Friday. Yeah. Yeah, that's all. Joe, do you have any plan to China or?
So Mihash
You
was
never been to China, right?
Yeah, I have never been. I think Mihash has been. He was considering
No,
this.
me.
I know he was considering
Okay.
going this
I will
year.
talk to him and then.
Yeah, I don't know if.
Okay.
Yeah. If
I
he
will
wants
confirm
to
with.
go,
Mhm.
maybe I can go with him.
So, how about that? You talk to Mihash, right?
Yeah,
Okay.
yeah. Yeah.
Yeah.
I'll ask him. Yeah.
Okay. Just remember, let me know before this Thursday. Okay.
Okay, I will ask him whether or not he wants to go.
Okay. Sure. Thank you. So I think we have run out of the time. So let's call it today.
Yeah, okay. Nice seeing you guys. See you next time.
Okay, see you next time.
All right.
Thank you, Jung Woo Song. I still cannot sure if I pronounce your name correctly.
Yes, you pronounced correctly. Well, my name is Jung, and you can call the Jung. Yeah, that's okay.
Thank you. Glad
Yeah,
to see you here. Thank you. See you guys.
see you.
Goodbye.
See you.